In this section, we're going to be talking about piecewise functions. So before we begin, we need to know what is a piecewise function. And it is a function defined by two or more functions. And each equation applies to a different part of the domain. Remember what domain is. It is your x values, right? How far left the graph goes, how far right the graph goes. So you'll notice in this section that it wants to know, here's my linear function, but it only wants to know when x is less than or equal to 0. So look at the graph of 2x plus 1. Here's where I begin, and I would go up 2 over 1, up 2 over 1, and then I reverse it. Notice I am only shading to the left-hand side of that linear equation. I'm not including this part because I don't care when x is greater than 0. All I care about is x being less than or equal to 0. So you only see the line on this side of the domain. On this part, x plus 3, here's where I begin. Notice it's open circle because it wants to know when x is greater than 0. So my slope is 1, up 1 over 1, up 1 over 1, up 1 over 1. So I am only wanting to know when x is greater than 0, this linear function. All right, so that's what that looks like over here. Now, when you look at evaluating the piecewise functions, you got 3 different functions going on and 2 in each set of functions. So this one says, okay, find your output when your input is 5 of the f function. So I got to go here. So if f is 5, that means it's going to be greater than or equal to 3. So I'm going to evaluate 5 in this linear function, 5 plus 7, and that gives me 12. Okay? Now, this says evaluate the f function when x is negative 9. Well, negative 9 is less than 3, so I'm going to plug in negative 9 to this linear equation. That's the one I'm going to follow, negative 36 minus 1, and that's going to equal negative 37. So I want to evaluate the g function when my input's negative 6. So that would be this function right here, because negative 6 is less than or equal to negative 2. So I'm going to input negative 6, and I get negative 9 minus 7, and that's going to be negative 16 would be my answer there. Now, on number 4, it says, okay, when your g is negative 2, that's equal to negative 2. So I'm still going to use this same one. And I get negative 10 is my answer. So let's look at an h function because we haven't done that before. All right, if h is negative 1, I'm not going to evaluate it when it's right here. I'm going to evaluate it when it's right here because it's equal to negative 1. Well, I have no option. No matter what it is, my output's going to be 3. That's my output. Now, when h is 6, that means I'm going to use this function. 5 times 6 minus 8, and I get 30 minus 8, and that's 22. So when my input is 6, my output is 22. So that's what it looks like there when you're evaluating an input, you still get one output. Okay, how do we draw these graphs of linear functions? Well, the first one I'm going to do is this guy here. So here's where it's splitting the domain. For this part, I want x to be less than or equal to 0, and for this guy, it's going to be greater than 0. So I'm going to work with this function here. So my beginning point's 2, and it's closed circle, and I go down 3 over 1, down 3 over 1, down 3 over 1, and I go up 3 over 1, up 3 over 1. I don't care about this side of the function, so I'm not going to include it. The only part I'm including in my linear function is everything that's less than 0. So the line looks like this. For this guy, I'm going to graph negative 3 is my beginning point, and it's open circle because x is greater than 0. And then I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And I only care about this side of the domain. So that's what my 2 linear functions look like. Now, if you look at the domain, of this piecewise function, all my values are going to go all the way left and all the way right. So that's all real numbers. My range, remember, right range is how far down to how far up. So it's going to go negative infinity to negative 3. So y is less than negative 3, or y is greater than or equal to 2. Okay? So let's do another example together. All right, let's look at 10 and 11. All right, so again, I'm splitting the domain where x is less than 0 and x is greater than or equal to 0. So again, I'm going to have my beginning points located on that y-axis. So let's start with this one. My beginning point's 4. It's going to be an open circle because x is less than. If I were to continue this graph, it would be up 2 over 3, up 2 over 3, and then I would reverse it, down 2 over 3, down 2 over 3. I don't care about this side of the graph. I just care about where my domain is less than 0. So I erase that part because I just want to know less than 0. Now for this function, it's going to be closed circle at 2. My slope is negative 1, so down 1 over 1, down 1 over 1, down 1 over 1. Okay? And where x is greater than or equal to 0. So that's what my linear function, piecewise linear function is going to look like here. Now, my domain, how far left does it go? Forever. How far right? Forever. So my domain is all real numbers. And my range is going to go down forever, and then it's going to go up to 1, 2, 3, 4. So y is less than 4 because all the numbers below 4 are included. All right, let's look at number 11. So again, I'm going to start, now look at my domain. My domain is split at negative 2. So that's the line that I'm going to follow because that's the line I care about. X is less than or equal to negative 2 or x is greater than negative 2. So I still want to graph this, so 4. My slope is down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and then I'm going to reverse it. Now I can get rid of, I just want to know when it's less than or equal to negative 2. So I can get rid of this side. I don't care about that. I just want to know when my domain is less than or equal to negative 2. So for this line, I'm still going to graph it. My beginning point is negative 1. My slope is negative 3 over 2, negative 3 over 2, and I'm going to reverse it, up 3 over 2. Now here, because it's on negative 2, it's an open circle. And then I only care about the right-hand side of that. So now this is my piecewise function. My domain, how far left it goes forever, how far right it goes forever, so my domain is all real numbers. My range will go down forever, and then it stops when y is 2. So y is going to be less than 2, or y is going to be greater than or equal to 1, 2, 3, 4, 5. Okay, so that's my domain and range. Let's look at writing piecemeal functions. So jump down to the bottom page. Okay, here we go. So I've got 2 different functions going on, right? 2 lines. So remember brackets and when we have more than one solution, so I'm going to bracket it. And I'm going to start with this guy. And this guy cares about when my domain is x is less than 0. Okay, so let's look here. My beginning point's negative 1. So on this one, my beginning point's negative 1. And my slope is negative, it's going to be positive. It's going to go up 3 over 1, up 3 over 1. So my slope is 3. So the line here is y equals 3x minus 1 when x is less than 0. Okay, that's my first one. If x is less than 0. Now my second line is going to be, my beginning point here is 1. My slope is 1 over 1. So my slope is 1. And so now my line is going to be y, excuse me, that's a good y equals x plus 1 if x is greater than or equal to 0. So I found my two equations and I gave the parameters of my domain. X is less than 0 and x is greater than or equal to 0. All right, let's look at this guy over here. Now the line that we're looking at is negative 3. So x is going to be less than or equal to negative 3, and then x is going to be greater than negative 3. So let's look at this line first. I'm introducing my function. I have two parts, so I'm going to have this first line. This beginning point is 3. My slope is negative 1. So my line is going to be y equals negative x plus 3 if x is greater than or equal to this one, if it's going to be greater than 3, negative 3. Okay, so y equals negative x plus 3 if x is greater than negative 3. This guy over here, I still want to find the slope, so I'm going to start with my slope, and it's up 2 over 1, up 2 over 1. If I continued it up 2 over 1, up 2 over 1, up 2 over 1, I would find that my beginning point is 7. So my beginning point is 7, my slope is 2. I don't really need that anymore. I just wanted to find my beginning point if I carried it out. So now, y equals 2x plus 7 if x is less than or equal to negative 3. So we have to be able to read them and write them as well. If you're struggling or if you have questions, come see me.